hours, which you know will never come into play till the last moment when we are ready to plug in numbers. Good, ready. What is given in the problem? And any suggestions on how to start? So what is 25? And
that's the velocity of the car going west.
Good, but how do I write it?
dv over dt.
You mean dx?
dx.
Good, perfect. Then?
It's going to be
dy over dt and dx over dt. Good. Anything that we can write that connects these three functions of time? X is a function of time, y is a function of time, and w is a function of time. Do we have any connection among these three? Anything that you can think of?
We got distance and we got time.
Right. Anything we can write with these three?
Can you use Pythagorean Theorem?
Thank you very much. How do I write it? Excellent, Jordan. Thank you.
X squared plus y squared equals w squared.
This equation has how many functions of time?
3.
Very good. Excellent. How do we proceed?
Derivative everything.
I'm ready. Great job.
X dx over dt.
Awesome.
And then 2y dy over dt.
Awesome.
And then 2w dw over dt.
Perfect. Of course, I'm going to keep it as a clean ship. 2 has to go away. So I have x dx over dt plus y dy over dt equals w dw over dt. What is the question? What are we trying to find? What am I solving for?
dw dt.
Exactly. That's why I put it in from the very beginning. I analyzed what I was given. So now I want to summarize the steps. First, I draw a picture. Very important. Secondly, I put on the picture what is given and what I'm really asked to do or whatever, right? In this case, it's a right triangle. Then I analyze or I come up with a correct notation for what I'm asked to find and when, which I will never look at till the very last step, but I have to have it there. Then I also analyze what I was given and write the correct notation in calculus terms. Then I try to find a function or an equation, in this case, an equation that relates what is happening here, like when we had x with y. But this time it's easier because I didn't need to use similar triangles, but I only had to look at the Pythagorean theorem. Then I analyze on the side, what is all this? 1, 2, 3 functions of time. So when I differentiate, I have to make sure that x, and I understand that x is not x. It's a function of time. Y is not y. It's a function of time. And w is not w, but like a variable, but it's a function of time. So now I clean it up. I already identified the fact that this is my variable. Everything else has to be determined somehow from the given information. So all I have to do is divide by w. So dw over dt will be whatever I have over w. So this is x dx over dt plus y dy over dt. I have my function that represents what I'm asked to find. And now I'm ready. This is the final step in which I throw in the numbers and calculate the final answer. Okay, so now let's see what are the numbers, what we have, what we don't. Obviously, I don't have W, so I have to come back here and do something to get W from there. But let's take it easy. What do we have and what we don't have? So
we have X and Y.
Say it again.
We have X and Y.
I don't have X and Y. I have dx over dt, which is 25. I have dy over dt, which is 60. But I don't know this distance after 2 hours, and I don't know this distance after 2 hours, but I can easily determine it. So how do I determine this, and how do I determine this? Once I have these two, I can find the W.
You just plug in 2 hours.
Exactly. Exactly. So distance equals rate times time. I have the rate of 25. So for x, the rate is 25 times 2 hours. For y, the rate is 60, but then times 2 hours. So can anyone give us x and y?
50 and 120.
50 and 120. So we have everything at the top. Now, how do I determine w? How will I solve this equation for w? What do I have to do to solve for w?
Plug in X and Y.
Right? So this will be the square root of x squared, which is 50 squared, plus y squared, which is 120 squared. I will write the numbers one more time for everyone to see. So let me put them one more time from scratch here. So dw over dt when t equals 2, one more time, is 50 multiplied by 25 plus 120 multiplied by 60. Everything's divided by the square root of 50 plus 120 squared. Careful how you plug it in. You have to use parentheses around the top. So left parenthesis. Do you want me to show with the sharing the screen, or is this okay?
We can see that.
You can?
Yeah, we see it.
Okay,
I can see
50
it.
multiplied by 20 plus 120 multiply by 60, close the parenthesis, and divide by the square root. You know me, I have to have parentheses. Some calculators don't require inside the square root, but I have to show for all calculators. So, and I trust myself with parentheses anyway. Okay, so I got 65. Measurement unit.
Miles per hour.
Of course, thank you very much. Again, picture, identify the rate that you are asked and when, identify everything you are given, create a relationship between the variables in the problem, which are functions actually, 3 functions of time, remember that. Differentiate implicitly, make sure that you use the correct formulas, if it's a product rule, quotient rule, or whatever, power rule, and then solve for what you're asked to determine, and then start plugging in numbers. And then the measurement unit at the end. Okay, ready for one more?
Yep.
I have a question for you.
Any question, please, please.
So, couldn't this problem have just been solved with the Pythagorean Theorem from the beginning? Since we knew 2 sides of the triangle?
Okay, tell me.
Well, because we knew 25 and 60, right? And then we could just a squared plus b squared equals c squared. So we could solve for that missing side. So 25 squared, right? Plus 60 squared. Square root it. And just that equals 65.
For the rate of change.
Yeah, for the rate of change, of course. And then we would have to plug in 2 hours into the rate of change.
So you would take the square root of 25 squared plus 60 squared, and you will get the 65. Is that what you meant?
Yeah, that's exactly what I meant.
For this particular it happened that in this particular situation this will work, but this is not going to happen in all situations. So these are the correct steps. If you say, okay, let me just, I realize that there is a relationship between their rates of change similar to this, because that's what happens. Okay. It just happened. I don't know if it'll happen in all situations.
Well, I didn't expect it to.
Maybe in all situations with Pythagorean theorems, when the Pythagorean theorem can be applied.
Okay.
It's a very good question.
Because I mean, you get the same answer regardless of which method you apply.
Right. The moral of the problem is not just to apply and see that, which is fine if it happens to work. The moral of the problem is to identify the variables, to identify the relationship, use implicit differentiation, realize that these are three functions of time, and then determine the function and plug in the numbers. That would be a shortcut, but it will not use calculus. And it will not have all the explanation from calculus why that happens.
Probably only works if it's a 90-degree, but
if it's if it's anything else, yeah. It will
Yeah.
not be the Pythagorean theorem. It could be the generalized Pythagorean theorem. So we do have a Pythagorean theorem in all triangles, so to speak. It's the law of cosines. So in any triangle, so the opposite side is always denoted by this lowercase corresponding to the vertex. So we have that a squared equals b squared plus c squared. This will be in the case of a quadratic, of a right triangle, but now minus 2bc cosine a. This, I learned it a long time ago as the generalized Pythagorean theorem. We call it also law of cosines. I wanted to write L of law of cosines. And of course, it can be written by rotation. I can have b squared, a squared plus c squared, and so on and so forth. So yes, in that case, it will not work. Okay, very good observation. Thank you. Very valuable. So let's take a look at two sides of a triangle are 4 and 5 meters in length. Two sides of a triangle are 4 meters and 5 meters in length, and the angle between them is increasing at a rate of 0.06 radians per second. Find the rate at which the area of the triangle is increasing when the angle between the sides of fixed length is pi over 3. I know it's a lot to take in. I'm going to read it again. We're going to draw the picture and everything. So we have a triangle. We are told that one side is 5 meters and the other one is 4 meters. And the angle between them, we are going to call it theta, is increasing at a rate of 0.06 radians per second. I have to stop and identify what this means. Let me read it again. Two sides of a triangle are 4 meters and 5 meters respectively in length, and the angle between them is increasing at a rate of 0.06 radians per second. What does this represent?
It's like the angle's getting larger.
Yep, in terms of calculus, what does this represent? I agree, fully.
d theta over dt.
Thank you very much, Derek. Perfect. Now we can read on. Find the rate at which the area of the triangle is increasing when the angle between the sides of fixed length is pi over 3. Okay, let me read the problem again. Two sides of a triangle, 4 meters and 5 meters. The angle in between is increasing at 0.06 radians per second. Find the rate at which the area of the triangle is increasing when the angle between the sides of fixed length is pi over 3. What am I asked to find?
dA dt.
Thank you very much, Jordan. Indeed. Let me refresh your memory on how we determine the area of a triangle. So if I consider this the base, then I have to determine the height coming down perpendicular, of course, from the opposite vertex. So I need this height because the area of the triangle is 1/2 base times height, and this is the height. But in this triangle, I could use sine theta, which is the opposite over the hypotenuse, and solve for the height. So that's a secondary formula, but it only works if I'm given two sides and the angle in between. So I will replace h by 4 times sine theta in here. So then the area of the triangle will be 1/2 the base, which is 5, times the height now, which is 4 times sine theta. So in general, the formula is, I'll come back in a second. Which page am I on? 12. Okay, so if I have A, B, and the angle in between, if I'm given A, B, and this angle, I cannot use it. If I'm given A, B, and this angle, I cannot use it. But A, B, and the angle in between, the area of the triangle is 1/2 times A times B times sine alpha. That's the alternative formula, but only if I'm given the angle in between. If I'm given these two and this angle, it doesn't work. So I found the relationship. So the area then, I'll simplify, is 10 sine theta. So the area is 10 sine theta. What do I do next? I'm asked to find dA over dt and how many functions I have in here and what are they functions of.
Functions of time.
Thank you very much. 2 functions of time. theta, and A. What follows next?
The derivative of
Good.
cos-
How do I write it? Very good.
dA over dt equals 10, and then cosine theta dE theta over dt.
Awesome. I'm asked to find this. I don't have to solve for anything. It's already there. When theta equals pi over 3. And that's it. I copy 10. How much is cosine pi over 3? 10, are you with us? You disappeared on me.
Oh yeah, I'm still here.
Okay, good. Cosine pi over 3. Anyone?
Cosine of pi over 3 is going to be 1/2.
Very good, awesome. And d theta over dt, I have it on 0.06. Very good. So this is 5. So this is 30.3. Measurement unit.
Units per second.
Radians per second. Radians squared per second.
Be the area.
Yes. Area is measured in
What, I don't know what unit we're given.
meters.
Meters. Meters a second.
Meters squared. Per second.
Yes.
Yeah.
It's the measurement unit of this over the measurement unit of this. Very good, awesome.